Here's a number that should scare you a little. The vast majority of cloud security disasters are not clever hackers breaking in, they're simple misconfigurations. Someone left a door open. The good news is that AWS gives you an incredibly powerful set of locks, you just have to know how to use them. And it all runs through one service, IAM, Identity and Access Management, the system that decides WHO can do what in your account. Over the next few minutes, we'll make security make sense, with pictures, the root account, users, groups, policies, root account, users, groups, policies, roles, MFA, and encryption, so you can lock your account down properly. Before any of that, the single most important idea in cloud security, the shared responsibility model. Security is a partnership, split into two halves. AWS is responsible for security of the cloud, the physical data centers, the servers, the networking hardware, the stuff you can never see or touch. They guard the building. But YOU are responsible for security in the cloud, your data, who you give access to, your passwords, your firewall rules, your encryption settings. Picture an apartment, the landlord secures the building and the front gate, but locking your own apartment door is on you. Almost every breach you read about is a tenant who left their own door wide open. So let's start locking doors, beginning with the most dangerous key in your entire account, the root user. When you first create an AWS account, you get the root user, the email you signed up with. It has unlimited, unstoppable power. It can do absolutely anything, including delete the whole account and close the billing. Because it's so powerful, the rule is simple and strict, you almost never use it. Set an incredibly strong password, turn on multi-factor authentication immediately, and then lock it away like a crown key in a vault. For your day-to-day work, you create separate limited identities, which is exactly what we'll do next. And whatever you do, protect every important login with MFA, multi-factor authentication. A password alone is one factor, something you know. The problem is, passwords get phished, leaked, and guessed all the time. MFA adds a second factor, something you have, usually a 6-digit code from an app on your phone that changes every 30 seconds. Now, even if an attacker steals your password, they still can't get in without physically having your phone. It takes about 2 minutes to switch on, and it blocks the overwhelming majority of account takeovers. Turn it on for the root user first, and then for every human user. No exceptions. Now for day-to-day access, IAM users and groups. An IAM user is a separate identity for one person or one application, their own login, their own credentials. The golden rule, one user per human, and never ever share logins, because shared logins mean you can never tell who did what. Then, instead of attaching permissions to each person one by one, you create groups like developers or admins or finance. You attach the permissions to the group once and drop people into it. New engineer joins, add them to developers, and they instantly inherit exactly the right access. Someone leaves, remove them, clean, simple, and auditable. But how do you actually say what someone is allowed to do? With a policy. An IAM policy is a small permissions document written in JSON that spells out the rules. Each rule has 3 parts: an effect, either allow or deny, an action, like read a file or launch a server, and a resource, the specific thing it applies to. So a policy might say, allow the read action on this one storage bucket and nothing else. You attach policies to users, groups, or roles. And remember one crucial tiebreaker, an explicit deny always wins. If anything, anywhere denies an action, it is blocked, no matter how many LOs you stack up. And the principle that should guide every policy you ever write is least privilege. It means grant the absolute minimum permissions needed to do the job and not one click more. It is tempting, so tempting, to just hand out full admin access to make an error go away. Don't. Every extra permission is another door an attacker can walk through if that identity is ever compromised. So start from 0 and add only what's actually needed. If an app only reads from one bucket, give it read on not one bucket, not write, not delete, not every bucket. Least privilege turns a total account takeover into a tiny contained problem. Now the concept that confuses everyone but is genuinely elegant, IAM roles. A user is a permanent identity with a password. A role is different. It's a temporary set of permissions that something can put on, like borrowing a badge, use for a short while, and then hand back. Nobody lives in a role permanently. The credentials it hands out automatically expire after a few hours. This is perfect for your applications. Instead of hard-coding a permanent password into your EC2 server, you give the server a role. It silently borrows short-lived credentials as it needs them, and there are no long-lived secrets sitting around to leak. Which brings us to a hard rule about access keys. A human logs in with a password. A program authenticates with an access key, basically a long username and password for code, and these are radioactive. The classic disaster is a developer pasting an access key straight into their code and pushing it to a public repository. Bots scrape those within minutes and run up a massive bill. So, for anything running inside AWS, like an EC2 server or a Lambda, use a role and 0 long-lived keys. If you absolutely must use an access key, never commit it to your code, store it securely, and rotate it regularly. Prefer roles, treat keys as a last resort. Next layer, encryption, so that even if someone does get to your data, it's useless to them. There are 2 kinds, and you want both. Encryption at rest scrambles your data while it's sitting in storage, in S3, on a disk, in a database, so a stolen drive is just gibberish. Encryption in transit scrambles it while it's moving across the network, which is what the padlock in your browser's HTTPS is doing. AWS makes this easy with KMS. The encryption keys for you. On most services, you switch encryption keys for you. On most services, you switch encryption on with a single checkbox, so there's no excuse not to. And one specific mistake to never make: hard-coding secrets. A secret is a database password, an API key, a token, anything that grants access. Beginners paste these straight into their source code, and the moment that code is shared, the secret is exposed forever. The fix is a dedicated vault, AWS Secrets Manager, or parameter store. Your secret lives there, encrypted. Your application asks for it at runtime using its role, and you can rotate it automatically without ever touching your code. The rule is absolute. Secrets live in a vault, never in your code, and never in a public repository. Let's turn all of that into a checklist you can actually run today. 1. Lock away the root user and put MFA on it right now. 2. Turn on MFA for every human user, no exceptions. 3. Create individual users, organize them into groups, and never share logins. 4. Apply least privilege everywhere, grant the minimum, prefer an explicit deny when in doubt. 5. Use roles for your applications instead of long-lived access keys. 6. Turn on encryption at rest and in transit. And 7. Keep every secret in a vault, never in your code. Work down that list and you have shut the doors that the vast majority of breaches walk through. Let's lock down PhotoApp specifically. The root account is sealed away with MFA and never used. The engineers each have their own user, grouped into developers, with least privilege policies. The web server doesn't carry any keys, it's given a role that allows it to read and write only the photo bucket and nothing else. The database password lives in Secrets Manager, not in the code, and the app fetches it at runtime through its role. Every photo is encrypted at rest in S3 and served only over HTTPS. If an attacker ever cracked one piece, least privilege means the blast radius is tiny. They'd reach one bucket, not the kingdom. Here's the whole security picture in one diagram. At the top, the root user sits locked in a vault, protected by MFA, untouched. Below it, human users live inside groups, and policies attached to those groups to grant least privilege access. Your application doesn't hold a password at all. It assumes a role and borrows temporary credentials. Secrets sit in the vault, pulled at runtime, never in the code. And around all of it, encryption wraps the data at rest and in transit. Notice the shape, identity in the middle deciding who can act, least privilege policies narrowing every door, and encryption as the final backstop. That is a properly locked down account. Let's bring it together. Security on AWS is shared. AWS secures the building, you secure what's inside. IAM is how you do your half. The root user gets locked away behind MFA. Humans get individual users sorted into groups, and policies grant least privilege, where an explicit deny always wins. Applications use roles for temporary credentials instead of long-lived keys. Secrets live in a vault, and encryption protects your data both at rest and in transit. Get those right, and you've closed the doors that almost every breach walks through. It isn't about being clever, it's about not leaving doors open. And that is AWS security and IAM sorted. Not a black art, just a set of locks, shared responsibility, a sealed root user, MFA everywhere, users in groups, least privilege policies, roles instead of keys, and encryption over everything. Run the checklist and your account is genuinely hard to break into. If IAM finally makes sense now, do me a favor and subscribe to Beyond Cloud. The whole point of this channel is taking the scary parts of AWS and making them simple, with pictures. The next deep dive is databases. Tell me in the comments what you want me to break down, and I'll see you in the next one.